Hello, everyone, and welcome back this time to Chapter 9 Embedded Systems. Those are like mini operating systems, as we just finished operating systems last week. So, embedded systems include their own operating systems called embedded operating systems. Both the GPS device and even an ATM machine likely have embedded systems that use embedded operating systems. So, as security professionals, we should understand that any vulnerability in a desktop or a server OS might exist because of its embedded counterpart, right? It's kind of like the Windows OS we talked about last week, that it's more secure, the current OS, but it still has this backwards capability so that it can interact with older OSs, right? It creates a vulnerability. So, for example, which makes it vulnerable to attack. The problem can be worse on embedded systems. Here's why. The hardware limitations and software compatibility become big issues. Software developers often omit security checks on embedded systems, such as input validation is a software development security check. And so because they're really trying to fit the code on the chip. You shouldn't ignore devices simply because they're small, right? That's a good lesson. And we want to perform simple tasks. Or if they haven't been exploited before, we don't want to ignore it, right? As a security tester, our job is to be identifying potential security problems. Now, these are our objectives today, and kicking it off with the introduction. So, embedded systems are any computer system that isn't a general purpose PC or server. So, we've been talking last week OSs, general PC or server OSs. Now we're talking anything else. Toys, kitchen appliances, printers, industrial systems, spacecrafts, etc. all have these embedded systems in them, right? And so any computer, again, that isn't a general purpose PC or server has an embedded system. I mentioned GPS and ATMs before. Lots of industrial items, lots of industrial items, and we'll get into that here in a little bit. So an embedded system operating system can be a small program developed specifically for use with the embedded systems, designed to be small and efficient. In fact, it's going to do really only one task. Now, the key benefit of embedded systems is their ability to work in real time, solving their tasks with little or no delay, such as such performance then really is achieved by optimizing the system resources and hardware to perform just that one activity. And because of this optimization, using an embedded system is really cheaper and less power consuming than building a more complex device. With the correct software, embedded systems can behave predictably and perform well in any environment. This is proven. These systems are also convenient for hardware engineers, as embedded devices are small and need few external connections. The drawbacks, though, in discussing the pros and cons, is that they also arise from their compactness, right? So what is a positive is also a negative. And so first off, limiting computer power and memory puts developers in a challenging position. They need specific skills and experience to create software that makes embedded systems permanent, stable, and secure. Anyhow, you can read more about the pros and cons. There's a great website called apriorit.com, apriorit.com. They have a lot of good information on there. I highly recommend it. One of the specialized embedded OSs is a real-time operating system called RTOS, right, which is typically used in devices such as programmable thermostats and appliance controls and even spacecraft, designed with an algorithm aimed at multitasking and responding predictably. That's RTOS, real-time operating system. That's a type of embedded system. So as you become acquainted with devices that use embedded systems, you need to think the way attackers do. In fact, through this whole course, we're trying to think the way attackers do. What system could you attack that could affect hundreds of other systems? Maybe even thousands of systems. For example, we learned back in physical security that one of the weaknesses is the hot and cold aisles of server rows, right? And so HVAC becomes critical. If I impact an embedded operating system on an HVAC, I could take down an entire server farm in short order by overheating. So an attack on an HVAC can have serious negative impact on the network infrastructure. So many embedded systems include firewalls, switches, routers have embedded operating systems, some web filtering applications, network area storage or NAS devices, printers, scanners, VoIP, thermostats we talked about, HVAC, fire suppression, closed circuit TVs, even an elevator management or a video teleconferencing that you do probably every day. These parking meters have an embedded system in them. So embedded OSs are easily hacked. In fact, this upset the city of San Francisco, who didn't think of hiring security professionals to conduct a vulnerability study, and found that they were hacked intentionally. Somebody said, hey, I'm going to prove you can. Many dismiss the topic of embedded device security to focus on the more popular issues. That happens all the time. That happened last week when we talked Linux and Windows, right? People talk the Windows OS vulnerabilities, but there are plenty of Linux, but it's just not the thing, right? But it should be considered as a security tester. So embedded systems are in all networks and perform essential functions such as routing the network traffic and blocking suspicious packets. In fact, recently researchers were able to reverse engineer the software on a popular firewall chipset, and the software residing on the chip is commonly called firmware. You've probably heard of that. And the researchers were able to insert modified software to control the firewall's behaviors. Well, imagine hackers could modify a firewall so that they can copy the network traffic passing through it, through this interface, and giving us external IP addresses, full access through the firewall. Imagine the value and quantity of targets within embedded systems. This is going to increase the attacker's focus, which is something we want to avoid, of course. Now, there is, for your own research, I put this in here, a Jeep attack. A Jeep attack was famous. In 2015, they attacked the Jeep's embedded systems. And notice the top headline: hackers remotely killed Jeep on the highway with me in it, right? And I think that happened in Ohio. But notice the next headline, a couple of years later: the Jeep hackers are back to prove car hacking can get much worse, right? So just because we fixed a problem doesn't mean we fixed a problem, and we always want to be vigilant. You can read those own articles. All you have to do is Google Jeep hack 2015. I prefer, and I have the cut and paste here, the wired.com articles. Very interesting. I think you'd enjoy them. So Windows and other embedded operating systems, they'll often use recycled code. This is common. A reusing of technology. This is really sound software engineering practices. It's called code reuse. Unfortunately, these practices introduce common points of failure, right? Because shared code increases the impact of a single vulnerability. In Chapter 8, we discussed the vulnerabilities in Windows and Linux again, right? And any vulnerability in those OSs might also exist in the embedded versions because they're using the code again. As you'll also learn, though, in Chapter 8, there are tools out there. The book emphasized MBSA, but I mentioned other tools available for discovering vulnerabilities in Windows systems. Now, some of those tools run an embedded OS review also. So, continuing with the Windows and embedded OS line of thought, the Windows API, that's an application programming interface. This allows users to write programs that can interact with Windows. That's what a Windows API does. So, for example, displaying things on the screen or getting input from the mouse or keyboard. And so all Windows programs, except console programs, must interact with the Windows API regardless of what language it's written in. So the API, like I said, is an acronym for Application Programming Interface. That's the software intermediary that allows two applications to talk to each other. Each time you use an app like Facebook, or send an instant message, or check the weather on your phone, you're using an API. So as APIs have grown in popularity, so too have the threats against them. Unfortunately, hackers are becoming adept at using companies' APIs to gain access to sensitive user information like names, locations, financial transactions, etc. So to defeat this, it would help to encrypt the data in transit and at rest. When you encrypt it, you're obfuscating, right? You're making hard to understand. You're obfuscating the nature and relationship of the data being handled by any call. There's also machine learning and heuristics. They have made detecting these types of attacks much easier, right? As machines learn patterns, right? Or heuristic, meaning rule of thumb. So machine learning and heuristics have made detecting these types of attacks much easier. Then there's a certain amount of defense that can be found in such technology, right? Leveraging data learned from users. So we watch users' behavior and we aggregate the data that shows us what is a baseline common behavior, right? Gives us that outlier behavior is now easily identifiable, right? So if I'm tracking the average person's user interactions by your API, I can set a baseline of who you are and what you do. And that helps me identify these extreme conditions. And I can compare that with obfuscation systems, the encryption, etc. And I can combine this with a heuristics-based detection, which can help mitigate attacks. There are other proprietary embedded systems out there. VxWorks has widely used embedded OSs developed by Wind River Systems and used in various environments, including spacecraft. VxWorks is also in space probes, telescopes, and Mars rovers, just to name a few. Now, the Green Hill software also produces a variety of OSs. They designed embedded OSs for the F-35 Joint Strike Fighter. This is a joint fighter airplane that probably dozens of countries own today, built largely here in the United States, but shared with, like I said, dozens of countries. This type of OS is called MILS, or Multiple Independent Levels of Security/Safety, MILS. So the U.S. military uses MILS OSs in high security environments and other organizations, such as those controlling nuclear power and municipal sewage plants. And they use them when separating privileges and functions is crucial. So the OSs use a microkernel, which sacrifices some flexibility for simplicity. Okay, so and QNX from the QNX software systems is a commercial RTOS. We talked about real-time